Very good morning. Today, in our session on Business Research Lab, we'll be talking about simple linear regression. In simple linear regression, we have two variables, the independent variable and the dependent variable. Both these variables are in scale form or they are continuous variable. Here, we are using independent variable or the values in independent variable to predict the values for the dependent variable. The independent variable is also known as predictor variable and it helps in predicting the values for dependent variable, that is criterion variable. We can have an example here today. The example is about 25 students who have been given a questionnaire having two variables. One variable is social support, how they can turn to their colleagues, friends, parents for support, and second is their psychological well-being. So we are measuring the social support and psychological well-being of the students, and the range of possible responses for social support is from 8 to 40, and for well-being it is from 10 to 70, with higher scores indicating a higher level of social support and well-being respectively. So we are using social support as a predictor variable to measure the psychological well-being of student, which is criterion variable. Coming to the objective here, when we talk about simple linear regression, we are basically looking at predicting the values of dependent variable using independent variable. The data requirements are dependent variable is continuous, and in our case of this example, it is well-being, whereas the independent variable is continuous in form, and in our example which we are talking, it is social support. Now coming to hypothesis test, when we are talking of hypothesis test, we are basically using null and altered hypothesis, and the null hypothesis is saying that there is uh, the independent variable does not predict the dependent variable. The alternate hypothesis says that independent variable predicts the dependent variable, and the regression coefficient, which is denoted by Greek alphabet beta, is taken up here. The null hypothesis will always be that beta is equal to 0. That is, here for this example, it is that social support is predicting psychological well-being of the student, is not predicting the psychological well-being of the student. That is null hypothesis. Whereas for alternate hypothesis, it is beta is not equal to 0, which means social support is predicting the psychological well-being. Now, how are we going to say that we are accepting either the alternate hypothesis or the null hypothesis? If significance, that is small p value, is equal to 0.05 or less than that, we will be accepting the alternate hypothesis. A research question, which is fundamental to understanding of what the problem basically is and what has to be answered here for the case of social support and psychological well-being is, does social support predict psychological well-being among college students? So that becomes our research question. And now we are using the data which is given here on 25 students, where the data has been collected on social support and well-being for analysis. So I'll be moving to the new file. I'll be moving to new share, and this share is the data file. So the data file is before you. The two variables are there before me, and we have sample size of 25. So that's there. I move to variable view, and I know the first variable that I've got is support. And then here in label, I'm writing social support. And as far as measure is concerned, I'm saying scale. If you look at second variable is well-being. The label is psychological psychological well-being, and the measure is again scale. So that's there. So if you look at data view, support and well-being are the two variables that we have got. So coming back and now talking about the analysis part. So I'm going for analyze. I'm going for regression, linear regression. Click on that and this emerges. Social support happens to be the independent variable. The psychological well-being is dependent variable. Just I'm moving to this statistics, and already if you look, estimates and model fit are already, you can say, by default clicked. So we are just, you can say, moving to continue, clicking on OK, and we are now with the output file, and I'm showing you the output file. So this is what the output file is, which is giving us the result. So before I start discussing on this particular result, let's, you can say, move back. I'm moving to the very process of how are we going to conduct the simple linear regression. So I'm moving back. So I'm saying whenever we are conducting simple linear regression, we go to analyze, we go to regression, we go to linear regression, click on that. And if you look, you have the things coming up this way. So psychological well-being is your dependent variable. Social support is your independent variable. The moment you have placed the two variables in their specific locations as independent or dependent, you simply click on OK, and there you are with the result. If you look here, the output file is showing you, you can see the variables which have been entered. Social support has been entered as, you can say, the independent variable, whereas the dependent variable is psychological well-being. If you look at the second part, model summary, we have something called R. So R is 0.49, and R square is something very important. We'll talk on that a bit later also, but it is 0.24. So that is what R square is. Next, when we are talking about the significance part, and if we are talking about the Pareto thing here, so ANOVA, you can say F value comes to 7.279 with a significance of 0.131. And if you look at the coefficient value which we have got for social support in relation to the psychological well-being, the t value comes to 2.69 something, and significance is 0.13, 0.013. And if you look at the significance of, you can say, ANOVA and significance of, you can say, t-test that we have conducted, they are same. So in case of simple linear regression, we'll find the significance being almost the same. That's there. So here, if the significance value is less than 0.05 or even equal to 0.05, we are going to accept the alternate hypothesis. So this answer is suggesting us that there is there is a meaningful, you can say, prediction of criterion variable because of the Pareto variable. That is what is being proved. And if you look at the effect size, I was talking on that effect size a bit earlier. So effect size is just related to the R square. So if the value of R square happens to be 0.01, effect size is small, 0.09, it is medium, if it is 0.24 or more than that, it is supposed to be large. So here you can see in our case, the effect size happens to be large. Let's move to the answer part before we, you can say, close up for the things. So we are moving to simple linear regression. The point I was talking here. So we know the example, the objective, the hypothesis, the research question, data we have used right now. Now, how are we, you can say, going to look at the, you can say, the summary and all that. So interpretation of result is something we did just right now, and then we talked about, you can say, um, the effect size. So this is what we are talking about, the effect size. It talks a lot about effect size that as far as Kohn is concerned, and for maybe you can say simple linear equations, simple regression equations, we have to, you can say, look at r square value. So r square value, which is 0.01, it is small effect size 0.09, it is medium effect size, and for 0.24 it is supposed to be a large effect size. And since for us in this example which we have done, the value of r square is exactly 0.2524, we are calling it as a large effect size. And how are we going to write the result? That's very important. A regression analysis was conducted with well-being as a criterion variable and social support as predictor variable. Social support was a significant predictor of well-being. Beta is equal to 0.49, and T within brackets TF is equal to 23, that is 25 minus 2, and the value is 2.698 was the answer, so I've just rounded it off to 2.70. P value is less than 0. Um, 0.05. Actually the value of p has been, p is less than 0.013 is the value we got from the you can say analysis, and it accounted for 24%. So r square is equal to 0.24, so it accounted for 24% of the variance in the well-being score. So this means that source support is accounting on 24% of, you can say, variance in the well-being score. So that is what the answer is. So that was all about simple linear regression and example. Please do watch the second video on the exercise question on simple linear regression, followed by the solutions on the other two questions, question 2 and question 3, on simple linear regression. So thank you to all. Thank you.